Hello students, and welcome to today's lesson on simplifying numeric expressions using the order of operations. Our essential questions for today are: first, what is the order of operations? And second, why do we use it? You might remember the order of operations as, "Please excuse my dear Aunt Sally." But for math class, I would like you to write it this way: P, E, MD with an arrow and AS with an arrow, and we'll talk about in a minute what this means. But this is how I want you to write the order of operations that are needed to simplify numeric expressions during our math class. So why do we use order operations in this order? Well, think about why there are rules for anything. They allow people to work and communicate together. The order of operations does the same thing. It allows people to work together mathematically and communicate the same amount, the intended amount. I want you to think about this. Think about 2 plus 3 times 5. 2 plus 3 times 5. How many different answers could you get if you did not use the order of operations? Well, if you did not use the order of operations and you could do whatever you wanted, perhaps you would choose to add first. So 2 plus 3 is 5, times 5 is 25. Or maybe you would want to multiply first. So 3 times 5 is 15, plus 2 more would make 17. If there were no order of operations by which you had to simplify it, you could get 2 different answers. And if there were no order of operations, essentially both answers would be right. So, a long time ago, after a great discussion, it was agreed upon that the order of operations would follow steps. And that would tell people how to do the order of operations. That way it didn't matter what language somebody spoke, what nation they were from, nor what teacher that they had. None of those could get in the way of math communication. If someone wrote an expression, no matter where the person was from or where the information was going, it would be interpreted the same way. The order that they agreed upon is: first, all parentheses would be solved. This expanded over time to include all grouping symbols, which includes brackets, absolute value, square roots, and fraction bars. So you can add absolute value on your guided notes. After all grouping symbols are finished, all exponents are evaluated. Then, multiplication and division from left to right. Multiplication and division are the same process. Think about dividing by 2. Dividing by 2 is the same as taking half of something or multiplying by a half. So they are the same operation, so we have to do them from left to right. Afterwards, we'll add and subtract from left to right. And in our recent studies of integers, we know that adding a negative is the same as subtracting a positive. So they are similarly the same operation, so we do them from left to right. This left to right idea with the multiplication, division, and the addition and subtraction is why I like for you to write the order of operations this way. Because then, when you visualize it, it says multiplication and division from left to right. That's the way the arrow is going. So let's look at this example, and we'll walk through the order of operations and see how we would simplify it. Now, we know this is a numerical expression, meaning it does not have any variables in it. It is only constants. So we know we'll use the order of operations to simplify it. Does this expression have any parentheses, any grouping symbols? And the answer is no, so we're finished with that step before we ever start. Does it have any exponents? Yes, right here. We have 4 squared. We know that 4 squared means 4 times 4. 4 times 4 is 16. Bring the negative down since it wasn't grouped with the 4. So we have negative 16 plus, and we just bring everything else down, 24 divided by 3 times 2. Now, reevaluate using our list. Do we have any more exponents? No, so we're finished with that step. Now the next step is to multiply and divide from left to right. Do we have any multiplication or division? Yes, we have both. We have division and multiplication. Which one comes first from left to right? The division. So we have positive 24 divided by 3. Positive 24 divided by 3 is 8. Positive 8. So we bring the rest down. Negative 16 plus 8 times 2. Reevaluate using our list. Do we have any more multiplication or division? Yes, we have multiplication. And it is the last multiplication we have, so that means we're finished with this step. Positive 8 times 2 makes positive 16. So we have negative 16 plus 16 as our last step. We only have addition left. Negative 16 plus 16 makes 0, because if you owe 16 and you have 16, then you will owe nothing, but you'll also have nothing. Now, let's take a look at this numerical expression. Notice, when we start asking ourselves about the parentheses, we actually have two types of grouping symbols. We have the parentheses, and we have the braces, or the brackets. We always want to start with what's inside. So, do you see how these parentheses are inside of the brackets? We need to do this first. 5 minus 2 is 3. Rewrite everything else. Now, we still have parentheses here, but there's only one number inside. So this is a simplified grouping symbol. Now, we have this one, but if you look inside of it, because we have to do it first, there are two different operations. There is subtraction and an exponent. Which one do we have to do first? Subtraction or an exponent? We need to do the exponent first. 3 squared means 3 times 3, which is 9. Then we rewrite, bringing everything else down. Now, do we still have parentheses? Yes. There's only one operation inside, so we just need to simplify that. 25 minus 9 is 16. Now, we still have a grouping symbol, but there's only one number inside, so it is now simplified. Do we have any exponents? No. Do we have any multiplication or division? Yes. We have 4 times 16. Remember, when it's touching, we know that's multiplication. 4 times 16 is 64. And when we solve that, we have simplified the numeric expression because there are no more operations. Look at our new expression. Does it have any grouping symbols? Yes, it has two sets, just like the last example. Work from the inside out. 4 plus 1 is 5. Bring everything else down. Now, we still have parentheses inside, but it's simplified. This isn't actually a grouping symbol anymore. It's multiplication because they're touching. So we need to simplify these braces. Negative 2 times 5 makes negative 10. Last step, we only have one operation left, and that's division. A negative divided by a negative makes a positive, and 20 divided by 10 is 2. So this expression has a value of 2. We can do the same thing for algebraic expressions if we know what the variable is equal to. Here we see that x is equal to 7. That means they have the same value. So instead of writing x, I can write 7. So I'll write 21 minus 7 plus 2 times 5. Think about our Daly's word substitute, to replace the value of. We replaced x with 7. Order of operations. Do we have any parentheses? No. Exponents? No. Multiplication or division? Yes. Positive 2 times 5 makes positive 10. So we have 21 minus 7 plus 10. Do we have any more multiplication or division? No. Do we have any addition or subtraction? Yes. 21 minus 7 is 14 plus 10. Notice I'm going left to right. Subtraction before addition because it's on the left. And last step is addition. 14 plus 10 is 24. So this algebraic expression, if x is 7, has a value of 24. Let's try this expression where x is 24. So we're going to substitute 24 for x. So we have 5 squared times, because it's touching, 30 minus 24. Our first step is to simplify parentheses. Our parentheses are 30 minus 24, which is 6. So now we have 5 squared times 6. Do we have any more parentheses that need simplified? And the answer is no, because there's only one number inside. Do we have any exponents? Yes. 5 squared means 5 times 5, which is 25. So we have 25 times 6. Do we have any multiplication or division? Yes, we only have one multiplication problem to finish with this expression. 25 times 6. Think 6 quarters, 150. So this expression has a value of 150. There are other grouping symbols other than parentheses and brackets, so I would like to show you some examples of these. Let's start with a fraction bar. For a fraction bar, you must simplify the top and the bottom separately before you divide. So we're going to do all the operations on the top first. Do we have any grouping symbols on the top? No. Do we have any exponents on the top? Yes, right here. So we have negative 22 minus 4. And I'm just going to carry the bottom along, 5 minus 3. Now, if you look at the top, there is now only one operation to simplify, and that's subtraction. So negative 22 minus 4. If you owe 22 and you owe 4, then you owe 26. Now, we have the numerator simplified. Our second to the last step is to simplify the denominator. 5 minus 3 is 2. So we have negative 26 over 2. Now remember, the fraction bar can be a grouping symbol or an operation. To start, it was a grouping symbol because there was more than one number on the top or the bottom. But now that there's only one number on the top and one number on the bottom, this is division. Negative 26 divided by 2. A negative divided positive makes a negative. 26 divided by 2 is 13. So this has a value of negative 13.